Here we're going to evaluate the definite integral using integration by parts. So our integral is going from 0 to 1 of the quantity x squared plus 1 times e to the negative x times dx. So the first thing we're going to do is we're going to let u equal x squared plus 1. And then dv is going to equal e to the negative x dx. Step 2, taking the derivative of both sides, we have du, which is equal to 2x dx. And now we need to take the antiderivative of e to the negative x. Okay, so let's go ahead and find the antiderivative. So the antiderivative of e to the negative x dx, if we let u equal negative x, du is equal to negative dx. So negative du is going to equal dx. And if we find the antiderivative with the substitution, we have e to the u, dx is negative du. So we had negative e to the u du, and the antiderivative of e to the u is e to the u. And then using the substitution, we'd have negative e to the negative x. So therefore, v is going to equal negative e to the negative x. Okay, so now let's go ahead and rewrite our original question. So we're going from 0 to 1 of x squared plus 1 e to the negative x dx. And so we have u times v going from a to b minus the integral a to b v du. So let's go ahead and put in our substitutions. So we have u times v. So we know that we have x squared plus 1 times negative e to the negative x going from 0 to 1 minus the integral going from 0 to 1 of v, which is negative e to the negative x times du, which is 2x dx. Okay, so let's simplify this a little further. So we end up getting negative e to the negative x times x squared plus 1 going from 0 to 1. If we factor out the negative and that minus, this becomes a plus. So again, this negative times that negative makes us a plus. And then we can factor out the 2 going from 0 to 1. So we have x e to the negative x dx. And so now we need to then integrate by parts this integral again. So we're going to go ahead and do that. So we're going from 0 to 1 x e to the negative x dx. Okay, and then we're going to let capital U equal x, and then we're going to let d capital V equal e to the negative x dx. And so then we know that the derivative with respect to x is going to be 1, so that's dx. And v is going to equal the same thing because we found it up here. So v is going to equal negative e to the negative x. So we got 0 to 1 x e to the negative x dx. And that's going to equal capital U times capital V minus capital V du. So we know that this is going to be x times negative e to the negative x going from 0 to 1 minus the integral of v du going from 0 to 1. So we have v, which is negative e to the negative x, times du, which is dx. So let's go ahead and simplify this. We have negative x e to the negative x going from 0 to 1. A negative times a negative is a positive. And then we're going to integrate from 0 to 1 e to the negative x dx. Well, again, we know that the antiderivative of e to the negative x is the same as what we got up here. So this becomes negative x e to the negative x going from 0 to 1. And the antiderivative of e to the negative x is going to be minus e to the negative x. And we're evaluating that from 0 to 1. Now we're going to go ahead and substitute that back into this problem here. So we know that we have negative e to the negative x times x squared plus 1 going from 0 to 1. And then plus 2 and then we're going to substitute that for this integral here. So 2 times negative x e to the negative x going from 0 to 1 minus e to the negative x also going from 0 to 1. Okay, so now let's go ahead and then distribute the 2. So we have negative e to the negative x times x squared plus 1 going from 0 to 1. If we distribute the 2, we have plus 2 times negative x e to the negative x going from 0 to 1. Distribute the 2 here, gives us minus 2 times e to the negative x going from 0 to 1. Okay, so what we may want to do is just factor out the negative as well. So if we factor out the negative, just makes our calculation just slightly easier there. We can now factor out the negative, so that's going to be minus 2, and then the negative is out here. So we have negative, and then let's go ahead and evaluate. So we have the first one, which is e to the negative 1 times 1 squared plus 1 minus e to the negative 0 times 0 squared plus 1. And we have minus 2, and this is going to be 1 times e to the negative 1 minus 0 times e to the negative 0 minus 2, and this is going to be e to the negative 1 minus e to the 0. So let's go ahead and simplify. So we have a negative here, and so 1 squared is 1, and then 1 plus 1 is 2, so we get 2e to the negative 1 minus e, 0 plus 1 is 1, and 1 times e to the negative 0 is going to be 1, so that's going to be 1 minus 2, and this is 1 times e to the negative 1, and then that's going to be 0 minus 2 times e to the negative 1 minus e to the 0, which is 1. Now let's go ahead and distribute. So I'm going to distribute the sign. So we have negative 2e to the negative 1 plus 1. And over here we distribute. We have negative 2e to the negative 1 plus 0. And then distribute there. We get negative 2e to the negative 1 plus 1. And let me correct that. That should be plus 2. Because we're distributing negative 2 times minus 1. So that gives us plus 2. So now let's go ahead and combine like terms. So we have our like terms here. When we combine those three, we get negative 6e to the negative 1. And then we have 1 plus 0 plus 2, which is plus 3. And therefore there is our solution.